Welcome to Lesson 5, Sequences, Lists, and Tuples. Lists and tuples are two of the fundamental data structures in the Python programming language, and we've already started to introduce the basic capabilities of these two data structures in the preceding two lessons. Here we're going to fill in all of the missing pieces about these data structures and take a look at some other interesting capabilities as well. We'll of course continue to create and initialize lists and tuples, but we're also going to demonstrate in this lesson how you can access with expressions the individual elements within a list or a tuple. We're going to demonstrate some basic searching and sorting capabilities that are built right into the language so that you can look through these data structures to find elements within them and also order the elements. We're going to talk in more detail about passing objects into functions and methods, and in particular we'll do that of course in the context of lists and tuples in this chapter. Now, lists are modifiable or mutable entities. That means you can change the contents of lists. You can also change how many elements there are in a list dynamically, whereas tuples are immutable. Once you define a tuple, whatever number of elements you have, that will be the fixed number of elements for the tuple's lifetime in memory, and you cannot change things like the order of the elements in the tuple or what types of objects those elements referred to. We'll continue by discussing some of the common list methods that are available to you for common list manipulations. And then we're going to get into a variety of functional style programming capabilities in Python. Now again, Python itself is not a functional programming language. It is a general purpose language with lots of capabilities for procedural programming, object-oriented programming, and also functional style programming as well. And some of the key features in this lesson that we're going to talk about are Lambda Expressions, which are basically super shorthand representations of functions that help you implement functional style programming in Python. We're going to look at built-in functions, filter, map, and reduce for common functional style operations. Filter is going to look through a collection of elements and only give you back the elements that match some condition that you specify. Map is going to take elements in a collection and turn them into new values, and in the case of filter you may wind up with fewer items than you started with, whereas in the case of map you'll always have the same number of items. And reduce is a technique for taking a collection of items and reducing them down to a single value. So for example, the sum function that we've looked at a couple of times now is an example of a reduction, and there's lots of built-in reductions plus the ability to create your own custom reductions as well. Now, many of the filter and map capabilities that you can do with the built-in functions also can be done with a concept called a list comprehension. So we'll talk extensively about list comprehensions in this lesson, and we're going to talk about a related concept called a generator expression, which looks very much like a list comprehension. The difference between these two things is that a list comprehension is a way to create a list with a concise syntax, whereas a generator expression only gives you one value at a time on demand. So as you need a value, you can request it and get the next value from the generator. We'll also start to talk about two-dimensional lists in this lesson. Now, two-dimensional lists are available to you, but not the typical way that you'll work with two-dimensional data structures in many Python programs. Later on, a couple of lessons from now, we're going to take a look at the Numpy library numerical Python library, which has built into it an array data structure for high performance multi-dimensional data processing, where all the elements in the collection are of the exact same type. And then separately, we're going to introduce in the Intro to Data Science section of that subsequent lesson the library called Pandas, which is a super handy library for dealing with both 1- and 2-dimensional data in Python. Finally, in this lesson, in the Intro to Data Science section, we're going to start introducing visualization, and we'll continue our discussion of simulation there as well. In particular, we'll look at 2 key visualization libraries, Seabourn and Matplotlib. Matplotlib is the foundation for Seabourn, and Seabourn basically makes it easier for you to use Matplotlib. As you'll see in this lesson and beyond, these 2 libraries are often used together to produce some very nice looking charts and graphs and interactive and dynamic visualizations as well.